A new super-Earth has been spotted by astronomers, and it's quite intriguing. This planet, called TOI 715b, is about 1.5 the size of Earth, which is why it's called the super-Earth. It's also relatively close to us in space terms, only 137 light-years away. For comparison, most exoplanets are hundreds of light-years away, and all the interesting stuff, like black holes and nebulas, are usually more than thousands of light-years away from us. So, could it be habitable? The habitable zone is an estimate of where a planet might have the right conditions for liquid water. This is what we call some distance from the star, where the temperatures on the planet should be okay-ish, and water should stay liquid on its surface. It's not super precise, because it depends on a bunch of factors like the type of star, how reflective the planet is, its size, and so on. Also, just being in this zone isn't enough for water to actually be there. The planet also needs the right kind of atmosphere and a few other things. So, we invented a stricter definition in 2014, the conservative habitable zone. It's a more precise term defining the best candidates that have liquid water. Otherwise, we get too many potentially habitable planets that are not actually habitable at all. The CHZ is based on how much energy a planet gets from its star compared to Earth. If a rocky planet gets between 40 to 85%, it's considered to be in the CHZ, no matter how far away it is from its star. These planets have a higher chance of being habitable. And yes, TOI 715b is located there. This super-Earth orbits the M-type star, also called red dwarf. It's a star that's much smaller and cooler than our Sun, about a quarter of the Sun's size and mass. But if the planet is located in the habitable zone, it's actually a better option for life. Red dwarfs live much longer than our Sun, a yellow dwarf. This also means that they have more time to form little creatures on their planets. And this red dwarf really is older than our star. Our Sun is 4.6 billion years old, and this star is 6.6 billion years old, give or take a few hundred million. It doesn't have much magnetic activity, so it's not dangerous. It doesn't flare up like younger red dwarfs. These flares can be super strong and might even hurt planets by taking away their atmospheres. Although some planets around it do have thinner atmospheres, it seems like this red dwarf has already gone all out. These red dwarfs are where we're looking for planets that could support life right now. Our super-Earth is really close to its star, zooming around it in just 19 days. Since the star is small and the planet is so close, the planet passing in front of its star happens a lot and looks really clear. This makes it easy for telescopes like the James Webb to study its atmosphere without needing too much time. Now, speaking of the James Webb Space Telescope, it's bringing us into a new era of understanding distant planets beyond our solar system. Imagine being able to see what gases make up the air on a planet millions of light-years away. James Webb will help us to find worlds that could support life. Right now, it's trying to figure out whether TOI 715b has an atmosphere. If it does, its atmosphere might be easier to spot compared to a planet that's drier and denser. And then we might get even more height because it would look like a good place for life. On top of all that, there might be another planet in this system, also in the habitable zone. We're not sure whether it's really there, it's just a candidate with a crazy name. But if it turns out to be real, it would be about the size of Earth. Also, it would be the smallest planet in the habitable zone ever spotted by the TESS telescope. Now, another cool thing about TOI 715b is that it cannot just have water on it, but be an entire water world. An ocean planet is a type of planet that has an ocean covering its surface or has subsurface oceans. They might not have much dry land because the water can cover everything. Sometimes the entire planet can be covered in other liquids, like lava or ammonia. When it comes to planets outside our solar system, we can't see surface water directly with our current technology. Instead, scientists look for water vapor in the atmosphere as a hint there might be liquid water below. And of course, we wonder if these planets can have life, hopefully not in the form of Leviathan-like monsters. Our models show that planets with oceans might be pretty common in our galaxy. This means there could be lots of ocean worlds out there waiting to be discovered. But the most important part about TOI 715b is that it's in the so-called small planet radius gap. If we give the planets a lineup, there will be those that are bigger and smaller than Earth. But there's a sudden gap in planets that are about from 1.5 to 2 times bigger than ours. Where are they? This gap is interesting to scientists because it tells us something about how planets form and change over time. It's not that planets don't form in this size range. They actually start off larger and then lose some of their mass, like a balloon gradually deflating. Perhaps it happens because of how they orbit their stars, with stars blowing away some of their mass as they dance around it, as our Sun does with gas from comet tails. This gap holds a lot of mystery, and planets, like our new super-Earth, are clues that could help us unravel it. We aren't sure whether it exists around red dwarfs. Maybe it's a gap in how dense these planets are, rather than in their actual size. So studying our discovered planet is even more interesting. It'll help us learn more about distant stars and their planets. Now, I mentioned TESS a while back. NASA's TESS, Transiting Exoplanet Survey Satellite, has been in space for 6 years now and has been incredibly successful. NASA launched TESS because we already found over 5,000 planets orbiting other stars, mainly thanks to the Kepler telescope. But Kepler mostly found large planets, not necessarily like Earth. We decided to focus TESS on finding smaller Earth-like planets around nearby bright stars, making them easier to study with future telescopes. Here's how it works. The camera observes stars and looks for changes in their brightness. If the brightness suddenly drops for a while and then gets back, it could mean there is a planet passing in front of it. But stars can dim for other reasons too. For example, flaring up or having dark spots on their surface, which is why we need to be careful with this data. TESS shows us the size and orbit of these planets. Then ground telescopes help determine their mass. With these 3 parameters, we can figure out what the planets are made of and if they're rocky like Earth or gassy like Jupiter. Yeah, you want to avoid Jupiter after taco night. One example of TESS's discoveries was the TOI 700 system. There, it discovered its first ever Earth-like planet, TOI 700d. This exoplanet also orbited a red dwarf, and it's even closer to us, about 100 light-years away. Unfortunately, it's unlikely to be habitable because the temperatures there are crazy. Another big discovery was made in the AU microscopy system. TESS discovered a planet about 4 times the size of Earth and another nearly 3 times Earth's size. This system has become a key area for studying how stars and planets form and change over time. TESS has also spotted a variety of other exciting finds, including supernova, hot worlds, and so on. And as it enters its 6th year, we can only expect more exciting findings to come. Perhaps we've all stopped to think at one point about what it would be like to live on another planet. I know I've had days like that. Gotta get away. And maybe even interact with other types of creatures that already live somewhere else in space. These days, such ideas sound more like something from a science fiction book. But in the future, permanently changing your address to another planet might turn out to be mandatory. Think of the stars in our solar system as a battery. Billions of years from now, its energy will be gone. Without its light and warmth, life on Earth can't exist. When you think about it this way, we have to hope that future humans will have found some other place to live by then. Thankfully, there's good news. Recently, scientists at NASA have announced that they have found a new planet that might be able to support life. They call it TOI 700e. It's roughly the same size as Earth, and it's located in a region of space where scientists think water could exist in its liquid form, which is crucial for the development of life. This planet is not the only one, though. Close to it, there's another promising planet which they call TOI 700d, but this one is further away from its star. Because of the distance from the main source of light, Planet D lies in a special area called the conservative habitable zone. In simple terms, scientists aren't sure whether life might exist on this one, but they don't exclude such a possibility. Planet E is in the optimistic zone, which means that it's possible that it has water and even an atmosphere. Hey, at least we have some options. The two planets are in a solar system that's only 100 light-years away from Earth, which is considered pretty close in space terms. NASA found these planets by watching the light from the star and measuring how it moves when a planet passes in front of the star. This is the first time that NASA has found a solar system with multiple planets that could have life. So far, scientists have found over 5,000 exoplanets, and they think there could be at least 10,000 more. Specialists at NASA are looking into the ways to figure out if any of these planets could harbor life. But they also say we might find forms of life we don't expect to see, and that we should be open to other possibilities. That's because we only know about what life can be by looking at our own planet. Sure, everything sounds enticing so far, but don't pack your bags just yet. As appealing as these new planets might sound, there's still one problem: getting there. Scientists have been researching for decades how people can stay in space and thrive for long periods of time. And history tells us it's no easy project. Back in 1962, John Glenn became the first American to orbit our planet. To circle Earth a mere 3 times, he had to go through months of technical and physical preparations. These days, advanced technologies help us investigate Mars better, and scientists have figured out that there is water and materials on the red planet that may be useful to people. It has sparked the idea of sending people to Mars to live there, just to begin with. The first manned Mars mission is scheduled for the late 2030s or early 2040s, if everything goes well. The plan is for this to be a round trip, but even if NASA manages to plan everything well, the round-trip journey will still take about 500 days. It all depends on Mars and Earth's positions in their orbits around the Sun. One of the biggest problems with living on Mars is gravity. For starters, the astronauts will arrive at the red planet after months of living in microgravity. It means it could take them a lot of time to physically get in shape before they could start exploring. That's because living in microgravity conditions heavily affects the human body. It might mean loss of bone and muscle mass, as well as a shift in the normal movement of body fluids, which tend to go upward. This can lead to pressure on the eyes and even problems with people's eyesight. But Mars is right here, in our own solar system. What about planets that are light years away? The answer is still up for debate. It may sound cool to travel really fast, like at the speed of light. So far, scientists believe it's not possible. Sure, we may have been able to create airplanes that travel faster than sound, supersonic aircraft, but it's not the same. There's quite a difference, actually. Light is about 1 million times faster than sound. Traveling at the speed of light would mean we could go from Earth to the Moon in 1 second, or from Los Angeles to New York in less than the blink of an eye. But what stops us, though? Some say it's energy. It may be possible to make something go really fast, but it'll take a whole lot of energy. In this case, engineers will need to find new ways to make things move in space. Right now, rockets use fuel that is similar to the gasoline you use in your car. But that's not very efficient when it comes to space travel. Other ways to push a spacecraft include using electric or magnetic forces. One promising idea is using a solar sail, which is like a large thin sheet of plastic that can be pushed through space by sunlight. Some spacecraft have already used solar sails, and scientists think they could go up to about 10% of the speed of light. If other planets in our solar system turn out to be inhospitable, and we can't invent spaceships that move fast enough, we might still have a choice. Secret Option C. It was first proposed by a scientist who wrote an interesting study about a special type of planet. It suggests that we might not need spaceships to move around and escape problems on our own planet. We could use planets that are not orbiting a star. They're called rogue planets. Ooh. Instead of gravitating toward a star, these lonesome space objects simply drift alone through space, doing their own thing. Think about it this way. Moving to Mars is like moving to an already furnished house. Regardless of how nice it would be, you would still have to adapt to it. You'd have to get used to how much light gets in through the windows every day, and to climbing up and down the stairs to get to the living room. Moving to a rogue planet means we'd start from scratch, building our own house from the ground up, perfectly adapted to our needs. Free-floating planets are usually seen as cold, dark, and not suitable for life. But if they have underground resources, they can be useful. They offer a constant surface gravity, a lot of space, and resources. They can also provide water and protection from space radiation. If we become an advanced enough civilization, we might be able to control the planet and even create new types of energy. So the next question would be where we could find such a rogue planet. It's hard to know how many of these there are in the universe, but scientists have found a bunch of them in one region of the Milky Way galaxy. Some rogue planets have been kicked out of their own solar systems because they were bad. No, not really. It was because of gravity, while others might have formed on their own. Either way, we don't want rogue planets to get too close either, at least not in the near future. The chances of a rogue planet entering our solar system are extremely low. But if it did, it could mess things up for us. Depending on its size, a rogue space object might divert other planets off of their course around the Sun, which could alter their exposure to light and warmth. And if it crashes into the Earth, well then, that would be a bad thing too.
We've discovered Kepler-22b, a small exoplanet in the Cygnus constellation. Seems like nothing important, right? But it's actually a big deal. This is the first planet located in the habitable zone that was found by the Kepler telescope. In other words, there may be water on this planet, and if there's water, there may be life. Kepler-22b can become our new potential home. So let's take a closer look at it. Actually, discovering new planets is not easy at all. Not all of them can be seen through our super cool telescopes, even the almighty Hubble. Sometimes, the stars are so small and dim that it's really hard to find them on a map. The same thing happened with Kepler-22. In such cases, scientists have to use a special method. First, they take a bunch of photos of the star in different periods of time. Then, they look at them and think, are there any dark dots on this star somewhere? And if they find one, that might be a planet. These photos actually help us to discover some very important stuff. Like, first of all, this planet exists. Secondly, here is its size, radius, and proximity to the star. And finally, will we be able to live there? Now we know that Kepler-22b is very similar to our planet and could potentially become a second Earth. It's also very close to us, only 635 light-years away. Yeah, it's about 3 quadrillion miles, but this is one of the closest options. Kepler-22, the star of Kepler-22b, is a yellow dwarf. It's very, very similar to our Sun. The same size, the same radius, even the age is almost the same, 4 billion years. The difference is only in luminosity. It's about 20% dimmer than the Sun. So, no matter how much you strain your eyes, you won't see this star in the night sky. The planet Kepler-22b is about 2.4 times larger than our Earth, and that's pretty good. More radius means more potential water and space to live. Although going from one city to another would take a while. It's scary to even imagine a 3-day-long plane flight. We don't know the exact mass of this planet, but scientists think it's bigger than Earth's. Actually, the mass of Kepler-22b can be up to 36 times greater than that of our planet. What does it mean? Vigorous gravity. If the planet is 36 times heavier than Earth, then gravity there will be about 6 times stronger. Can you barely lift 20 pounds of potatoes? Try 120. Not to mention that you yourself can become much heavier on that planet. You'll have to get incredibly pumped up just to walk there. You have to literally turn yourself into a bodybuilder just to get to work. The worst thing is that with such gravity, it'd be incredibly difficult for plants to survive there. They'd need at least a little freedom to rise up from the ground. And animals. Our dogs and cats would have to turn into little balls of muscle to survive there. But if this planet has its own animals or other inhabitants, we can roughly imagine what they may look like. They probably have a lot of legs to make moving easier. They aren't really tall, but they're very massive and extremely strong. Muscular giant spiders? Could be worse, I guess. The good news is that this is all unconfirmed information. If we're very lucky, and gravity there turns out to be just a bit stronger than Earth's, then, of course, it'll be much easier to live there. The next thing we know about Kepler-22b is that it's about 15% closer to its star than we are to the Sun. If Kepler-22b existed in our solar system, it would be located somewhere between Earth and Venus. Does that mean we're all going to burn? No, silly. As I mentioned before, the star Kepler-22 is pretty cold, just some 10,000 degrees Fahrenheit. And that's why we can assume that the temperatures on Kepler-22b will be about the same as we have on Earth. If the planet orbits its star the same way Earth orbits the Sun, which we don't actually know, Kepler-22b can rotate around its star on its side, like, for example, Uranus. What? Didn't you know Uranus is actually lying on its side? Also, look at its rings. Yes, Uranus also has rings, like Saturn, but they're vertical. The universe is truly a mysterious place. So, if Kepler-22b is really something like that, then the weather on the planet will be, to put it mildly, not very good. Incredibly cold winters will be regularly followed by hot summers. And, just like with tidally locked planets, we'd be able to live more or less comfortably only on the narrow piece of land between these two crazy sides. Let's hope that this is not the case and the planet rotates normally. But it's not all that bad. Studies show that there may be an ocean on Kepler-22b. You already know that water means life, but in this case, it's also a big plus because a planet covered by an ocean always has more stable temperatures. The water absorbs some of the heat and distributes it evenly across the planet. The hot parts cool down, and the icy ones warm up. By the way, that's exactly what happened to Earth billions of years ago. When our planet started getting its first little puddles, our beloved moon helped these puddles to spread all over the planet. Thanks to this, a burning horror that used to be our Earth turned into a cute little ball full of life. So, if Kepler-22b has water but no atmosphere, scientists think that the average temperature there could be around 12 degrees Fahrenheit. But if there's also an Earth-like atmosphere, then the temperature can reach 72 degrees Fahrenheit. That would be nice. And finally, 1 year there is equal to 290 Earth days, about 9 months. The planet has no natural satellites, so unfortunately, we'd have to say goodbye to a beautiful view of the moon. On the bright side, we'd probably be able to see the sun as a distant little star. We could admire it in the night sky, remembering our home, while not hiding from giant spiders. And this is all that we know at the moment. Unfortunately, it's quite difficult to explore such planets, so there's a lot of very important data that we don't know. For example, what kind of planet is this anyway? Yep, we're missing the most important information about Kepler-22b. We don't know if it's a rocky planet or not. And if not, then all the previously mentioned information means nothing. It may turn out to be a gas planet, or a planet covered with gas but with a solid core, like Neptune, or a water world covered with a giant ocean. In this case, it better be a water planet. Then at least we could build some kind of underwater city there. We could filter the water and eat fish, until we evolve into an amphibious species. Does it even count as evolution if we go back to our roots? Scientists, however, think that Kepler-22b may turn out to be a Neptune-like planet. Some astronomers have even assigned the planet to a category of mini-Neptunes. Yes, this is a real planetary category. But this hasn't been proven yet. But even if, fortunately for us, Kepler-22b turns out to be a rocky planet, we still don't know what the atmosphere is like there. Does it exist at all? What if it turns out to be something like the atmosphere of Venus, which is more toxic than your ex? Then we'd have to dig deep underground to somehow survive on this planet. And then we'd have to come up with a heat source, because it's pretty cold underground. Yeah, let's hope this won't be the case. There are many possibilities with Kepler-22b. So far, we don't have a clear answer. But let's hope that scientists will find it before we load the first people into shuttles and send them to conquer Kepler-22b. That would be awkward if it turns out to be a gas planet, or something like that.
The only life that we are certain about so far in the entire universe is on planet Earth. Whether that life is intelligent is, let's say, arguable. But anyway, it's not surprising that we're tirelessly searching for life on other planets. So far, they've discovered more than 4,000 of them. But what's even cooler? NASA has compiled a new list of 24 planets that aren't just Earth-like, they're better. The conditions on them are so good that they're more comfortable than on our planet. So let's examine some of them. KOI 5715.01. Let's be coy, shall we? This wonderful planet is in the constellation Cygnus. And why is it so wonderful? Well, our sun is a yellow dwarf. And sorry, sun, even though you're not bad at supporting life, there are some stars that can do it better. Nothing personal. The planet KOI 5715.01 orbits near an orange dwarf. Orange dwarfs are stars slightly smaller than our sun and have a little lower luminosity. Did you like the alliteration there? Anyway, don't worry, it doesn't mean we're going to live in complete darkness. In fact, if the planet is found closer to the sun and it has a thicker atmosphere, it may even be lighter and more colorful than on Earth. Now, our sun has a very short lifespan. Right now, it has 7 to 8 billion years left to live, a little longer than Earth's age. But orange dwarfs can live from 45 to 70 billion years. This is great not only because we'll be able to hang out on this planet longer, but also because the planets around these stars have more time to form life. Now, ideally, we would need to find a planet next to an orange dwarf that is about 7 billion years old. It's very likely there will be at least some organisms there. KOI 5715.01 is about 5.5 billion years old. Yeah, it may not seem mature enough, but that's okay, neither do I. Our Earth is a billion years younger, and that didn't stop us. The planet is quite close to its star and is in a habitable zone. 1 year there lasts 190 days. Imagine going to elementary school and already getting a driver's license. It's almost 2 times larger than the Earth. The average temperature there is 52 degrees Fahrenheit, which is slightly less than ours, 57. But it mostly feels warmer there because strong gravity helps it hold on to heat in the atmosphere longer. It's a little too far away though, like 3,000 light-years from Earth, which is about 18 quadrillion miles. Yep, better bring a really big lunch with you. KOI 3010.01. This planet is found next to the star KOI 2010. This planet sounds like a very pleasant world. The average temperature on this planet is 67 degrees, so a little warmer than ours. But that's a good thing. Scientists believe that on a perfect planet, the temperature should be just about 10 degrees hotter than on Earth. The more heat there is on the planet, the more comfortable it is to live there. Also, the higher chances of developing life. The radius of this planet is nearly 1.5 times larger than Earth. There's some atmosphere, although we're not yet sure about its composition, but it's probably like the Earth's. Scientists think that we'll find an ocean there, and it can cover up to 60% of the surface, which is also cool. In a perfect world, water and land should be distributed more evenly than on our planet. A little more land means a little more territory and resources, right? But listen, This planet is actually very similar to the Earth. The semblance is so striking that scientists believe we have an 84% chance to find life there. Of course, not necessarily an intelligent life, but at least some animals. Wouldn't that be cool? Now, what do you think they could look like? Very Earth-like planet, but with stronger gravity. Well, if someone lives there, they're probably big but have a small height and strong little legs. Sounds adorable and scary. But we won't be able to find out the truth anytime soon. So far, for us, these planets are microscopic dots in space. We only have some dry, boring data about them and don't even know what they look like. We'll have to wait until we can find a way to get closer to these planets. Kepler 186f. This is also one of the best candidates for having life. This rather cute planet was nicknamed the Earth's cousin because it does have a strong resemblance. Anyway, these two planets are like sisters, not twins. Kepler 186f rotates near a red dwarf. Red dwarfs are stars even dimmer and smaller than orange dwarfs. Yeah, they'll also live for a very, very long time, but their luminosity is also quite low. However, Kepler 186f is closer to its star than we're to our Sun, so it shouldn't be too dark there. Well, at least not night-like dark. The sky on this planet is sure to be an unusual shade of red, like sunsets on Earth. What do you think? Would you like to live on a planet with an eternal sunset? The size of this planet is about the same as Earth. Not bad, not perfect. Why so? Because the coolest planets are those that are bigger than Earth and have stronger gravity. Now you'll probably say, but wouldn't it be harder to walk there and even harder to get out of bed on Monday? Of course. But on the other hand, this planet will pull the atmosphere better. The atmosphere will be thicker and denser. This means more protection from the scary space stuff, more oxygen, and more heat. Not to mention the fact that the bigger planets have more space to settle. Awesome, right? But of course, the Earth's size is also an excellent choice. Another cool fact is that the tilt of Kepler 186f is about the same as ours. It means that there should be stable seasons and a normal day-night cycle. Do you know how important the tilt of the planet is? Let's look at Mars. Mars is also, in fact, found in the habitable zone of our Sun. But its tilt is very unstable, and as a result, the entire ocean that could have been on it once now completely dried up. Today, it's just a red desert, and there's no life there. At least not as far as we know, but you see how important these tiny details are? This planet is also quite far away from us, 490 light-years. That's about 3 quadrillion miles. So yeah, we're just going to keep waiting for intergalactic travel. Kepler 62e and 62f. These planets were called the most Earth-like before we discovered Kepler 186f. They're very comparable to our home. Kepler 62e is about 1.5 times larger than Earth, and Kepler 62f is just slightly smaller than that. They're located in the constellation Lyra, which is about 1,200 light-years away from us. They both also orbit a red dwarf. 1 year on Kepler 62e lasts about 122 days, even less than on that first planet we talked about. Scientists believe that both 62e and 62f are sort of water worlds, warm places mostly, or even completely covered with water. If there is land there, it's probably just some islands. A world consisting entirely of islands. A fantasy dream for some, think Hawaii, and a nightmare for others, think Megalodon. But if you're a fan of ancient marine animals, just imagine how gigantic they could be there. Still, there are many things we don't know about this planet. Does it have a surface? What about its composition, density? One day, maybe we'll be able to answer these questions. And so, that's it for the super-Earths. Of course, the original list is much longer, and you can go check it out on the internet. Now, the best thing about all this is that these are planets that are better than the Earth. But we also know thousands of other exoplanets that are just close enough to ours. And the odds are, a few of them have at least some form of life. But they're very, very far away, so we have no way to check it out right now. Perhaps, down the road, we'll find some cool creatures on many of them.
Colonizing other planets is like the ultimate cosmic adventure. It's a challenge that's captured the imagination of humans for centuries, and it's something we've always dreamed of doing. One of the most popular candidates for this role is Mars, and this isn't surprising. Mars is a rocky planet that is similar to Earth in many ways, and it even has evidence of water on its surface. This makes it a prime candidate for human colonization. Many scientists and engineers are working on plans to send humans to Mars and establish a permanent settlement there. But what about the other candidates? There are many planets and moons in our solar system, so why not colonize something else? For example, Ceres. Ceres is the ultimate cosmic treasure trove. It's a dwarf planet, not a full-fledged one, just like Pluto. It's located in the asteroid belt between Mars and Jupiter. This dwarf planet is the closest to the Sun, and it's adorably tiny. The entire planet is about the same size as the state of Texas. So why choose it? Because Ceres may be a rich source of valuable resources. The surface of Ceres is covered in craters and other geological features, and scientists believe that beneath its surface, it has a thick layer of water ice, which means that deep underground, it may have an ocean of liquid water. If this is true, Ceres could be a valuable resource for future space missions. It could potentially provide a source of water for human exploration of the solar system. So, can we colonize it? And if so, how do we do that? Actually, many scientists and space enthusiasts have proposed this idea. To colonize Ceres, we'd have to use the same methods used to establish colonies on the Moon, Mercury, and the satellites of Jupiter and Saturn. Don't worry, it's not that hard. We just need to figure out how to adapt to a very thin atmosphere, to extreme temperatures, and pressure, and, well, all the other nasty stuff. But let's stay hopeful. At the end of the day, it all comes down to resources. We'll need water, minerals, silica, and other raw materials. All this would help us to create a self-sufficient colony. And luckily, Ceres is full of these things. So, first of all, we could locate the places of residence inside the craters of Ceres. We could build domes there that would protect us from all sorts of dangerous things, like radiation. We could also mine regolith in the asteroid belt. Regolith is a residual soil that appears as a result of cosmic weathering of the rock. Basically, it's something like the surface layer of soil on the Moon. Why do we need it? Well, because we could use it to 3D print the base layers next to the ice, so that our bases would be located near the water. We could then use these base layers to print other structures, like houses. We could also collect ice and organic molecules to create water. And by combining water with regolith, we would get soil in which we could grow plants and food. Wonderful! There's also another option. A colony could be created underground. That is, right next to the icy crust of the planet. Now, if in the future we'll be some kind of super cool scientists, we could try to accelerate the rotation of Ceres, which sounds crazy, but would be pretty beneficial. It would help us to create artificial gravity inside the underground colonies. And speaking of gravity, all of these things may sound cool, but let's discuss the difficulties that lie ahead of us during colonization. To colonize Ceres, we would need to overcome a number of challenges. To begin with, we need to develop technologies that will help us even get to Ceres. We need some kind of ships that would be capable of long flights into deep space. For them, first we need to create some kind of nuclear thermal or nuclear electric traction, and maybe an even more advanced type of fuel. Then we'll also need technology to help us sustain life in this small rocky world. That is, tools to extract and use local resources. Also, since there's no atmosphere on Ceres, we would have to wear spacesuits and live in pressurized habitats. And this is only the beginning. Living on the planet itself won't be an easy task either. For example, What about extreme temperatures, or radiation, or the mentioned incredibly weak gravity? The latter is definitely one of the biggest problems. The gravity of Ceres is only 3% of the Earth's. You wouldn't want to accidentally fly into outer space while playing football, would you? But the fact that any jump could send you on an endless journey isn't the only problem. Even if you somehow stay on the surface of the planet, you'll experience the same symptoms and problems as astronauts who hang out on the International Space Station. For example, loss of muscle mass, decrease in bone density, deterioration of vision, problems with the cardiovascular system. Wow, who would have thought that gravity is so important? So therefore, if we wanted to survive on Ceres, we would need either a bunch of doctors or some kind of artificial gravity. And don't even get me started on how low gravity will slow down production and work. And of course, we can't go anywhere without discussing money. Colonizing Ceres would cost us a huge expense, especially taking into account all of the above. And yet, despite all these things, Ceres still stays one of the best candidates for colonization. For example, Ceres contains lots of methane and ammonia. They can be used as a manufactured fuel or a nitrogenous gas. Or you can just mine it there in order to colonize Mars and Venus. Even low gravity has its advantages. Thanks to it, it will be very easy to launch spacecraft from Ceres. We'll waste much less fuel, which means that transportation from Ceres to other planets would be much cheaper and more efficient. So, even if Ceres doesn't become our permanent residence, it can become a good transport hub, something like a spaceport. We could use it as a base for mining all sorts of useful things from the asteroid belt. Then, we could transport all these resources back to Mars or Earth. And it can also become a refueling station for ships traveling further beyond the solar system. Sounds cool and pretty sci-fi-ish, doesn't it? But it seems that any attempts to create a permanent base in the asteroid belt will have to wait. Colonizing other planets is a difficult and complex task. It'll require the cooperation and expertise of many different people, and it will involve developing new technologies and overcoming many challenges. Before we go to Ceres, we need to build infrastructures on the Moon, Mars, and somewhere in between. Otherwise, any attempts to colonize it would be prohibitively expensive and would most likely fail before future missions could even reach it. But the more colonies we create, the more likely it is that sooner or later we'll build another one on Ceres. This would not only open the asteroid belt to economic exploitation, it would also serve as a stepping stone to the outer solar system. This, in turn, could lead to colonizing the moons of Jupiter and beyond. In other words, the rewards of colonizing Ceres could be great. Not only would it allow us to explore and understand this fascinating world, but it could also provide us with valuable resources that could help us to further explore and settle the solar system. Life on Ceres would likely be challenging, but exciting, as humans would be making a new home for themselves and exploring the mysteries of the universe. Just imagine all the new planet-themed restaurants and shops we could have. Welcome to Ceres Mart, where everything is out of this world! So, if you're a fan of cosmic treasure hunts, Ceres is surely a rich and rewarding destination. Just make sure you bring some weights on your feet so you don't fly anywhere.
We've been focusing on trying to find life on Mars so much, while there is this gem waiting to be explored. This planet is the 6th farthest from the Sun and the 2nd largest in the solar system. You'll find it right behind Jupiter. I'm talking about Saturn, or as they sometimes call it, the jewel of the solar system. It's so different from our planet. First of all, you wouldn't be able to stand there. While Earth consists of rock and other tough stuff, this planet is like a giant ball, mostly made of gases. If you found a swimming pool huge enough to fit Saturn, you could see the planet floating in the water. No wonder, Saturn is the least dense planet in the solar system. It also contains a lot of helium. You know, the gas you put in balloons to make them hover in the air. Saturn is a very windy planet. Winds there are more than 4 times stronger than the ones we have on Earth. A day over there lasts 10 hours and 14 minutes because Saturn spins on its axis pretty fast. But the planet takes its time while going around the Sun. A year there equals 29 Earth years. Saturn's radius is more than 36,000 miles. It means the gas giant is 9 times wider than our planet. If Earth was the size of a nickel, Saturn would be as big as a volleyball. Even though some of our planets in our solar system also have rings, Saturn's are the most spectacular ones. You can even see its rings from Earth. And no, you don't have to be a scientist with insanely expensive equipment. All you need is a small telescope. Saturn's rings are not firm. They are made of pieces of dust, rock, and ice. Some of them are as small as grains of sand, and some as big as a house or even a mountain. These are actually bits of asteroids, comets, and shattered moons that fell apart before reaching Saturn. They could be torn into pieces by the planet's powerful gravitational pull. Saturn has over 50 moons, and recently, scientists have discovered some unusual hydrothermal activity on one of them. Enceladus is Saturn's 6th biggest moon. It has 4 tiger stripes close to one of its poles. Researchers have found that there is an ocean underneath these stripes. Water and ice erupt from that area, so now we can't but wonder, maybe there's life out there. In the oceans on Earth, some forms of life gather around similar hydrothermal vents. They feed on the chemicals there, same as plants on the surface do with sunlight. And not only that, some of the oldest microbial life on our planet feed on the same energy as the one produced beneath the ocean's surface on Enceladus. It could potentially mean there's life developing there right now. Of course, it takes millions and millions of years for even the simplest organisms to appear. But hopefully, scientists will need less time to find more complex forms of life. There are millions of exoplanets out there in space, and scientists have been searching for those that could be potentially habitable. Exoplanets are planets orbiting a star outside of our solar system. Dwarf stars are similar, less luminous than the Sun. They sometimes live for more than 10 billion years. That's enough time for a living organism to develop and evolve into a more complex form. Life might appear on the planets orbiting such dwarf stars, or, like with Saturn, on one of their moons. And here it is, Gliese 876b, that orbits the red dwarf star Gliese 876. This planet is mostly a mystery, but scientists assume this is a gas giant that has no solid surface. They believe its atmosphere doesn't have clouds, but there might be water in its liquid form on the planet's surface. T Gardens b orbits a red dwarf that's around 12 light-years away from our solar system. The planet's mass is just a bit higher than that of Earth. Scientists think it may have a rocky surface. The planet needs around 5 days to complete its orbit. It means that 1 year on T Gardens b is actually shorter than 1 week on Earth. Somewhere far, far away, there's another potentially habitable planet named Kepler 1638b. Okay, to be more precise, it's 3,000 light-years away from Earth in the constellation Cygnus. This planet is 4 times as heavy as Earth and twice as wide. It needs almost 260 days to complete 1 orbit around its star. The gravity on this planet is stronger than that on Earth. It wouldn't be an easy feat to jump on its surface. 1 more Kepler coming along. This time, it's Kepler 62e, a planet that's more than 1.5 times the size of Earth. Scientists believe this one has a warm, humid, and hospitable atmosphere with cloudy skies. There are 1,200 light-years between Earth and this planet. Kepler 62e needs 122 days to orbit its red dwarf star. Its neighbor, Kepler 62f, is another potentially habitable zone. It's a world around 40% bigger than Earth. Scientists think this planet might be covered in water. The oceans on our planet are full of interesting creatures and organisms of all sizes, so the chances are this planet also hides some intriguing living beings, or at least it has the potential to develop life. When we say habitable, it doesn't mean life definitely exists there. It just means there are conditions for some forms of life to develop. LHS 1140b is a planet located in one of the potentially habitable zones. Unlike its gas companions, it's solid and quite rocky. The planet's radius is 60% larger than that of Earth, and its mass is 7 times bigger. It's one of the densest planets found out there. Since the planet has a big mass, an atmosphere there must be rather thick. Plus, gravity on its surface is much stronger than here on Earth. That's why you would likely have problems just standing on that planet. Hello and greetings from TRAPPIST-1, an ultra-cool dwarf in the constellation Aquarius. It's around 39 light-years away from us. 7 Earth-sized rocky planets are orbiting in the star's habitable zone. All of them can potentially have some water on their surfaces. The temperature on these planets is more or less similar to that on Earth. On the Moon, gravity is only 16% of what we have on our home planet. That's why the astronauts could hardly control their movements when they visited our natural satellite. But when it comes to the gravity on TRAPPIST-1 planets, you would probably feel good and comfortable there. And Kepler once again. This time it's Kepler 452b. It's a rocky planet 60% larger than Earth. Its parent star is similar to our Sun. This planet has actually spent around 6 billion years in the habitable zone, while Earth has been there for a mere 4.5 billion years. This planet needs 385 days to orbit Kepler 452. This star is around 20% brighter than our Sun, but has the same temperature. The whole system is very far from our little oasis. It would take you 28 million years to get there. And now, how about KOI 7711.01? It's another intriguing world 1,700 light-years away from us. This planet is only 30% bigger than Earth. It gets almost the same amount of heat as we receive from our Sun. Sometime in the future, people might start colonizing the galaxy. They would be looking for new planets to live on. Then we'd certainly have to make really long trips, and maybe one day we'd reach Proxima Centauri. It's a nearby star that has a couple of planets we could potentially inhabit, like Proxima Centauri b. It's around 4 light-years away from Earth, and it doesn't sound that far at first, but it actually is. It would take about 6,300 years to travel there, if we use the technologies that are available these days. It would need many, many generations to make a trip like that, and it would take even longer to finally inhabit that new world. People would be born and raised on spaceships. They would live their lives there without ever seeing either Earth or the planet they're heading to. Instead of trees, mountains, and rivers, there would be only the dark nothingness of faraway galaxies spreading in front of them. They would never be able to wander unknown streets, breathe in the fresh air, feel the wind. The only place for them to travel to would be another part of the ship. Certainly, such a journey wouldn't be simple, but it would pay off if people managed to build some more beautiful worlds, like the one we have here on Earth. Is that even possible? Time will tell.
Hey there, Earthling! If you think you're special because you live on the only habitable planet out there, think again. What makes a planet suitable for life? A whole bunch of factors, like the planet itself, its neighbors, and the star it orbits. A habitable planet is basically one that can sustain life, with things like access to water, energy sources, and nutrients. Earth, for example, is in the sweet spot, known as the habitable zone, where it can have liquid water on its surface. But just being in this zone doesn't automatically mean a planet is habitable. Factors like crazy levels of radiation can make a planet uninhabitable, even if it has the right temperature. So the bottom line is, we need water, something to orbit, and a set of nutrients of chemical origin that can be found in Mendeleev's periodic table of the elements or those funky snacks you buy. Look at this exoplanet called K2-18b. The term exoplanet doesn't mean that it's exotic. It just states that this planet is located outside the solar system. Most planets need to orbit something, unless we're talking about rogue planets that are basically planet-sized things floating around in space but not orbiting around any star or brown dwarf. Instead of our Sun, K2-18b orbits a red dwarf called K2-18. It's not your average star you can see with the unaided eye in the night sky. This one is hard to observe because of its low luminosity. K2-18b is indeed a planet far, far away. It's located 38 parsecs away from Earth. 1 parsec is somewhere around 19 trillion miles. Hey, you do the math. Hint, lots of zeros. K2-18b is a sub-Neptune, meaning that it has a smaller radius than Neptune. However, it's much bigger than our humble abode. It's about 2.6 times the radius of Earth. As for the weight, K2-18b is way chunkier than Earth. It's about 8 times as massive. It takes 33 days for this planet to go around its star, and it gets just about as much starlight as Earth gets from the Sun. This planet has a light intensity of 1.28 times greater than Earth and has an equilibrium temperature of 28 degrees Fahrenheit. Nope, it doesn't mean that K2-18b feels like New York in January. It only gives us an idea of the theoretical temperature put there. The planetary equilibrium temperature is basically the temperature a planet would have if it was perfectly balanced in terms of radiation. It's when the amount of heat leaving a planet is the same as the amount of heat coming in. Now, the trillions of miles that set us apart aren't a problem for potent telescopes, such as the Kepler Space Telescope that discovered this planet and the James Webb Space Telescope that is studying its atmosphere now. In 2019, scientists announced that they had found water vapor in the atmosphere of exoplanet K2-18b, which sparked widespread interest toward this outlandish world. 4 years later, the Webb telescope detected carbon dioxide and methane swirling in the air of this guy. Carbon dioxide is basically our best friend here on Earth. Humans need it to breathe properly and keep our blood pH in check. And plants love this stuff too, because it helps them make oxygen through photosynthesis. Obviously, we can't survive without it. Without methane either. However, this little gem got some scientists buzzing with excitement even more due to the discovery of some funky dimethyl sulfide gas molecules in its atmosphere. In 2023, scientists from the University of Cambridge spotted carbon-based molecules like methane and carbon dioxide hanging out on K2-18b with the help of JWST. This could mean that this exoplanet might feature a hydrogen-rich atmosphere and a watery surface. There's a potential whiff of dimethyl sulfide or simply DMS in the mix. On Earth, this stuff is usually linked to life, since it's normally produced by photoplankton in the oceans. The fact that we're picking up hints of DMS on K2-18b is like finding a golden ticket in the cosmic chocolate bar. Hey, kinda gives you the willies now, doesn't it? Why is DMS so important, you ask? Well, it's a bit of a superhero on our planet, playing a crucial role in the sulfur cycle and even affecting our climate by helping clouds form. And spotting DMS on other planets could be a sign of life similar to ours. Looks like this planet is a nice spot with its not that rough temperature and all the right nutrients to keep us alive. So, what's your take on its overall look? It probably took the planet a good few million years to come together. While things might heat up deep down underground, it shouldn't make a big difference on the surface. Some experts believe it could be home to a water or molten lava ocean with a hydrogen-rich atmosphere resembling a gas giant like Uranus or Neptune. Now this one doesn't really match our Earth standards, since our atmosphere is mostly made of nitrogen. If there's an ocean, it's likely under a thick layer of ice and rock, which could mess with the planet's climate. Once things get really hot, the line between the ocean and the sky blurs. We're not totally sure if there's a liquid ocean on K2-18b, and it's tricky to see one from afar. Just looking at the planet's size and weight won't give us the answer. The whole liquid water-ocean thing is up in the air. Initially, we thought water in a supercritical state was most likely, but new observations point toward a liquid ocean. Suspicious gases like hydrocarbons and ammonia might be moving from the air into the water if there's an ocean, which could mean no clear line between the sky and the sea. But some experts say a molten rock ocean could be doing the same trick. Others think a gas-rich mini-Neptune setup could explain things too. The Hubble Space Telescope did some snooping and found that K2-18b is rocking an atmosphere filled with hydrogen. They think there might be some water vapor hanging out there too, but it's a bit of a mystery. Apparently, the James Webb Space Telescope got a peek and saw less than 0.1% water vapor, possibly because the planet has a dry stratosphere vibe going on. As for ammonia, it's nearly non-existent in that distant world. Methane and carbon dioxide seem to be dominant in the atmosphere, making up about 1%. But don't expect to see any other carbon oxides crashing the party. Their concentration is just a guess at this point. The atmosphere of K2-18b is just a small fraction of its total mass, around 6.2%, and has probably got a similar vibe to Uranus and Neptune. Haze-wise, there's not much going on, and water clouds are a bit of a mystery. They're probably icy, although there's a chance for some liquid water clouds too. Now, besides water, the atmosphere could also contain some ammonium chloride, sodium sulfide, potassium chloride, and zinc sulfide clouds, depending on what the planet is into. And it seems like things might get a bit turned up high in the atmosphere, with the temperature inversion causing a stratosphere situation, just your average day in outer space. So far, scientists have come up with several climate models this planet might have. For example, some of them think that there's the same temperature across the whole planet, unless the planet is spinning super fast and the temperature difference between the poles and the equator is minor. But these are all speculations at this point. The amount of radiation K2-18b gets from his star is similar to what Earth gets. The temperature on the planet might be anywhere from really cold to pretty warm. Whether it can support life depends on its atmosphere and clouds. Scientists think microorganisms from Earth could survive there, even with all the hydrogen. But it's still hard to tell if there's life on K2-18b because the gases we usually look for might not work in its atmosphere. Scientists think the James Webb Space Telescope might be able to detect different markers of life on the planet with enough observations.
Hey Mythbusters! Today we're debunking some classic space myths. Hop on the next space shuttle and let's get to the bottom of these tales once and for all. Picture this. You're floating weightlessly in space, sipping on a cup of delicious hot chocolate, when a peculiar thought pops into your head. Can you scream in outer space? And if yes, would anyone hear that scream?
If you've watched the movie Alien, then you know the answer to this one. You can't hear sounds in outer space.
It's not that sounds don't exist.
It's just that you can't hear them.
There's no one better to clarify this myth than Chris Hadfield. He's been on a couple of spacewalks during his life as an astronaut. And once you're out there in the darkness of space, you can't hear anything.
All you hear is silence. Complete silence.
But hey, just around the corner is a massive ball of explosion, aka the sun. We just can't hear the explosions happening because there's no medium for sound to travel through. It would be quite uncomfortable for an astronaut, though, if they could hear all the noises going on in outer space. Now, imagine you're zipping through space, feeling like a futuristic superhero, when a shooting star passes by your side. But wait, is it really a star? Unfortunately, shooting stars are not stars at all. They are small space rocks known as meteoroids, entering Earth's atmosphere and creating a stunning light show. Oh, and since we're debunking myths, let's head straight for another one. You've probably heard that meteors only crash into Earth on extremely rare occasions, like once every dinosaur extinguishing apocalypse. That's not true. Scientists estimate that about 48 tons of meteoritic material fall on Earth each day. But almost all of this material is vaporized in Earth's atmosphere. The bright trail we see in the night sky is what we popularly call a shooting star. Next time you make a wish upon a shooting star, remember, you're actually hoping on a tiny piece of space debris. It's not so romantic after all. Can we or can we not fly into the stratosphere on air balloons? Apparently, we can. The Earth's stratosphere starts relatively close to the ground, about 7 or 8 miles up from the Earth's surface, but it continues a long way up. If you were to fly yourself all the way into the stratosphere with some type of air balloon, just make sure you have really good equipment at hand. You'll need a special suit and some breathing devices because air starts to get pretty thin the higher you get. Of course, if you do go all the way up, you need to get a picture of the Earth's curvature. So take a chest harness with you where you can put a special camera or something like that. And how about you live stream the whole thing? That would be a first! Imagine it's been 102 days since you left Earth. You've adapted well to life in outer space, but something weird is happening to your body. You're getting taller. How is that even possible? Don't stress about it, it's completely normal. The truth of the matter is, you're not getting taller. This is what happens to your body when it's not under the effect of gravity. Our body has natural space between vertebrae and joints. On Earth, this space is almost completely squeezed due to the force of gravity. But in space, your body gets some time off of the pushing force of gravity and begins to stretch more and more. So yes, astronauts can grow up to 3% taller when they're on long missions. And here's a curiosity. NASA has that all covered when they're tailor-making spacesuits, of course. This way, astronauts will always have extra space in their suits. Once astronauts are back on Earth, the anti-gravity effect will wear off. So maybe they'll spend a few days wearing capri pants before it fits perfectly on their bodies again. Never have I ever pictured an airplane door bursting open mid-flight and a bunch of passengers being sucked into the atmosphere like flying feathers. Well, I'm betting most of you have had similar thoughts when getting inside a plane. Now imagine if this were to happen in outer space. Common knowledge says that if an astronaut is sucked out of an airlock, this person would be burnt to a crisp. Brace yourselves, because this is not only true, but the reality of it is way worse. According to astronaut Chris Hadfield, this is what would happen. The part of your body in the shade of the sun would experience temperatures of negative 418 degrees Fahrenheit, while the part of you getting sunlight would burn at around 480 degrees Fahrenheit. Your lungs would collapse, and your blood would start to boil like tea water. So you would burn, freeze, lose your ability to breathe, and boil. Yikes! How many times have you heard that astronauts have to work out every second of every day, otherwise they'll pass out? This is a complete myth. Remember we talked about gravity earlier? Due to the lack of gravity in outer space, our bodies don't have to do any heavy work. Our torsos don't have to sustain the weight of our heads, and we don't have to make any effort to move our legs because, essentially, there's no walking in outer space. Now imagine living like that for 6 months, or even a year of your life. Your muscles could turn into jello. That's why astronauts work out. They'll strap themselves and run on a treadmill, or they'll do some weightlifting in a special machine. This way, their muscles won't feel the lack of gravity too much. They do need to keep hydrated though. You know what? If I was an astronaut, I'd ask NASA if I could take my super soft water flask up into space with me. You've probably heard that space smells like burnt steak or barbecue sauce. Now, as much as this sounds absurd, this myth is more true than it is false. Astronauts obviously can't smell space when they're in it because they can't take off their helmets. They usually smell it once a space vehicle docks and they open up a hatch. Apparently, what causes this smell is the presence of hydrocarbons that float around in space. Who would have thought, huh? Hey smart people, let me ask you a question. Do you really think that if astronauts fly at the speed of light, they won't age a single second? I knew you'd say no. Let's get a few things straight. First of all, we haven't figured out how to operate vehicles at the speed of light. This would require an immense amount of energy, and we don't have the technology to do that. Second, even if we managed to send a human inside a spacecraft that traveled at the speed of light, this person would still age. They would age differently than the people who remained on Earth, that's a fact, but they would still age. Do you lot really think there's such a thing as immortality? Nah. If you've seen the first Avatar, then you certainly remember that humans only managed to get to Pandora because they traveled in cryosleep. In other words, they froze their bodies, put them in a cryobed, and traveled for years without aging. Yes, this sounds amazing, but we still don't have the technology to do that. Our bodies are mainly made out of water, right? And when you freeze water, it expands. That's why you should never leave soda cans unattended in your freezer. Right now, if we froze a person's body, the water inside of it would expand, harming tissues and organs. So no, we can't cryosleep our way into interstellar travel. Not yet, at least. Here's a crazy thought. What would happen if an astronaut took a drone with him on one of their spacewalks? Unless it's a NASA-designed drone, maybe the thing would freeze and burn like humans would if they went into space without a suit. But hey, a person can dream, can't they? An exoplanet is any planet inside our solar system. Some of them are free-floating. Those are called rogue planets. They move around the galactic center. Others orbit their host star, or two. For the first time, astronomers discovered exoplanets in the 1990s. Since then, scientists have found thousands of them. And now, you can sneak a peek too. Spoiler alert, some exoplanets are pretty bizarre. Others resemble our home planet and could probably support life. The closest to Earth exoplanet is Proxima Centauri b. It's a mere 4.2 light-years away from Earth. Recently, astronomers have found out that this world might resemble Earth even more than previously thought. It's only 17% more massive than our home planet. It orbits a star that is dimmer and less massive than the Sun. Proxima Centauri b is in the middle of the star's habitable zone. This means that chances are liquid water and life might exist on the planet. It looks like the exoplanet is tidally locked with its parent star. This means one of its sides faces the star at all times, and the other is always in the darkness. Scientists haven't figured out yet whether the planet has an atmosphere. It's traveling too close to its star and completes one orbit within 11 Earth days. The radiation from the star might be pulling the planet's air away. If this is the case, Proxima Centauri b isn't likely to have liquid water on its surface. Gliese 832c is 16 light-years away from Earth. In the cosmic scheme of things, it's a stone's throw away. This exoplanet is 5 times as massive as Earth and travels much closer to its parent star. That's why a year on this planet lasts a mere 36 days. But since this star is a red dwarf, much cooler and dimmer than the Sun, Gliese 832c gets as much light and heat as our planet does. At the same time, it's still unclear if Gliese 832c is similar to Earth. It probably has a much thicker atmosphere that creates a runaway greenhouse effect. This phenomenon occurs when a planet absorbs more heat from its host star than it can release back into space. This means that Gliese 832c is more likely to resemble scorching hot Venus rather than relatively cool Earth. Another Earth-like planet, TOI 700d, is 100 light-years away from us in the constellation Dorado. It orbits a small and rather cool dwarf star that is about 40% of the mass and size of the Sun. Its surface temperature is half as high as that of our star. The outermost planet, which is the very TOI 700d, is almost the size of Earth. It also sits in the habitable zone of its parent star. No flares from TOI 700 reach the planet. This increases the chances of the exoplanet being habitable. This means it can potentially develop and maintain life. Scientists don't know for sure the exact conditions on the surface of the planet, but one of the computer simulations they've created shows a planet covered with an ocean. It has a very dense atmosphere dominated by carbon dioxide. Astronomers think a similar atmosphere surrounded Mars when it was a young planet. But another 3D model shows TOI 700d as an all-land, cloudless world. That's what our Earth would probably look like if it wasn't covered with oceans. Winds on TOI 700d move away from the night side of the planet and meet in the area that directly faces the star. There is an exoplanet that stands out among the rest because of its awesome magenta color. You can find this world in the Virgo constellation. The planet is called Gliese 504b. The distance between this planet and its parent star is 9 times the distance between the Sun and Jupiter. The planet formed relatively recently and is still glowing with heat. That's why its surface looks pinkish. Just 20 light-years away from the Sun, which isn't such a great distance when we talk about space, a bizarre rogue planet is roaming our home Milky Way galaxy. But even though this planet doesn't orbit any star, it still has an incredibly powerful magnetic field. It's 4 million times stronger than Earth's magnetic field. The exoplanet also produces amazing auroras. When it was discovered in 2016, astronomers were almost sure they had detected a brown dwarf, which is an object too large to be a planet and too small to be a star. But later, scientists received proof that the space object wasn't big enough to be a brown dwarf. The planet sure is a mammoth among its peers. It's 1.2 times as wide as the largest planet of the solar system, Jupiter, and more than 12 times as heavy. Astronomers think the exceptional strong magnetic field helps the planet produce the auroras. But the most curious thing is that they're generated in a different way than auroras on Earth. It might be because the exoplanet's moon helps the planet create these light shows. If you traveled 20,000 light-years away from Earth, you'd come close to a red dwarf in the Sagittarius constellation. Such stars are very cool and small. Quite far away from this cold star, there's a planet. The distance between this world and its host star is so great that the planet receives very little heat. It's one of the coldest planets ever detected. The average surface temperature on the planet is lower than -360 degrees Fahrenheit. That's why the entire planet is covered with a thick layer of ice. If you stepped onto its surface, you'd see nothing but glaciers, plains, and mountains of ice. And still, astronomers claim life might exist deep beneath the frozen surface. All because the core of the planet is likely to generate enough heat to melt some of its inner ice. In this case, there would be an enormous subsurface ocean, maybe even swarming with bizarre life forms on the planet. One of the oldest exoplanets we know about is PCR B162026b. It's about 12.7 billion years old. It's almost 3 times as old as Earth, which appeared 4.5 billion years ago. This also means that the Genesis planet formed only about 1 billion years after the Big Bang. The planet is so old that its 2 parent stars have had enough time to evolve into a white dwarf and a pulsar, making almost 100 revolutions per second. Sunrises on this planet must look awesome. I bet the next exoplanet isn't like any other you might have seen before. It's often called Super Saturn or Saturn on steroids. That's because J1407b has a colossal system of rings. They're 640 times as large as those of Saturn. The bizarre world is 434 light-years away from Earth. It's the only planet we know about that has rings similar to Saturn's. If you moved J1407b to our solar system and replaced Saturn with it, its rings would look many times larger than a full moon. Astronomers have noticed a gap halfway through the planet's rings. The chances are high that an exomoon the size of Mars orbits the planet somewhere within this gap. If you lived on this moon, you'd have an awesome view every time you looked up into the sky. This exoplanet, called WASP-12b, munches on the light coming from its star. It's one of the darkest worlds people know about. All because its day side consumes light rather than reflects it back into space. The planet is giant, twice the size of Jupiter, and it traps more than 94% of the light that reaches its atmosphere. This is likely to be the main reason for the insane temperatures on the surface of the planet. They can rise up to 4,600 degrees Fahrenheit. It's almost half as hot as the surface of the Sun. WASP-12b travels so close to its host star that it needs just 1 day to complete one orbit. Its night side isn't as hot as the day side, a mere 2,200 degrees Fahrenheit. Because of this difference in temperature, water vapor and clouds gather above the surface of the planet. From time to time, swirls of material from the planet's superheated atmosphere spill onto its star. About 4,000 light-years away from Earth, there's an exoplanet that might be one enormous diamond. It's 5 times the size of our planet, but needs only 2 hours and 10 minutes to orbit its parent star. It's a pulsar rotating at a rate of 10,000 times a minute. The planet is denser than any other we've discovered so far. It consists mostly of carbon, which is so dense that astronomers think it might be crystalline. If it was true, it could mean that at least some part of the planet is diamond. On WASP 76b, it rains iron on the night side of the planet, and the temperature on the daytime side rises up to 4,300 degrees Fahrenheit. That's hot enough to vaporize most metals. This exoplanet is a bit smaller than Jupiter and located 640 light-years away from Earth. Such terrifying weather conditions in this world are caused by its unusual orbit. The distance between WASP 76b and its parent star is 10 times shorter than the distance between Mercury and the Sun. That's why the star and the huge planet are tidally locked. One side of WASP 76b always faces the star, and the other side is always pitch black. This bright blue exoplanet sits 62 years away from Earth. A bit larger than Jupiter, it looks calm and peaceful. Its blue color might remind you of our home planet. But this familiar appearance conceals the planet's horrifying nature. The beautiful hue comes from silicate atoms and particles that make up the atmosphere. But the wind speed on the planet can reach 5,400 miles per hour. That's 7 times the speed of sound. The temperature there can rise up to 1,600 degrees Fahrenheit. But this isn't the worst. In this bizarre world, it rains glass, sideways. So it's probably not the place where you'd like to spend your vacation. Imagine you're stepping on board a once-in-a-lifetime Arctic expedition that departs to the east coast of Cape Bathurst in Canada's Northwest Territories. It's said that the location you're headed is unmatched on planet Earth. The final destination is an unbelievable location known as Smoking Hills. These red-striped rocks have been burning there continuously for centuries. It has minerals there that are only found outside our planet, on Mars. Some scientists even believe that the site can be an important case study for discovering life on the red planet. On board the small cruiser ship, you head out to the deck and spot an unusual scene on the horizon. You see clouds of smoke forming close to a seaside hill. It's as if a party of hundreds of people did campfires all at the same time. But this smoke is not man-made, your guide tells you. Naturally, most people guess it's a volcano. Some people on the deck even guess that an eruption might happen anytime soon by the looks of it. Your guide laughs, explaining that this is far from the case. Volcanoes are usually found on the edge of tectonic plates. It's a rupture on the crust of the Earth that allows hot lava and gases to escape to the surface. In the Smoking Hills, the story is different. The constant smoke is caused by a natural phenomenon. But you'll learn all about it over the next few days. As strange as it may sound, these rocks didn't begin burning yesterday. According to experts, the ground on Smoking Hills has been releasing clouds of smoke for at least a couple hundred years, non-stop. You heard it right, but experts are still unsure how long they've been burning. It could be thousands of years. Now, before you leave the ship, some instructions are in order. The expedition leader explains you're going to enter a high-risk place. So, we replace your regular hiking boots and clothes with a special suit and gas mask before stepping on site. The clouds of smoke you are now watching from a safe distance are composed of sulfuric acid. This chemical is highly toxic. You need to be careful while breathing its air. So remember to keep those masks on. Oh, and as tempting as it may look, don't touch anything with your bare hands. Legend says that the first crew to explore the Smoking Hills found it by mistake. And imagine, these people had none of the gear you're going to use. First written records on the Smoking Hills date back to the 1800s. Irish explorer Captain Robert McClure led an expedition to find the lost explorer Sir John Franklin and had disappeared for over 5 years. The crew took a wrong left along the way and stumbled upon these burning rocks. They also thought it was an active volcano, much like you did, but they discovered how wrong they were when they stepped on site. McClure got curious and took a sample rock back to the boat, and the story says it burnt a hole through his mahogany desk. Remember this when you feel like taking a souvenir home with you. It might not burn a hole on your desk, but it sure will fly through your pocket or any container you try to use to take it. Now it's day 2, and you're ready to explore the location. The expedition's crew is divided into smaller boats. On your way to the shore, you notice a group of animals. They are far from the smoke, and it looks like they have themselves a mealtime. The smoking hills are located in the Arctic tundra, and there are rich fauna and flora nearby. Slowly, you're approaching the shore. Now you see the cliffs are made of red striped rocks that look like they've been hand-painted by someone. There's another place on Earth with similar hills, and it is located in Peru, all the way to South America. The so-called Rainbow Mountain or Seven-Colored Mountain is a mesmerizing natural phenomenon. They are formed by the sediment of different materials. While the smoking hills are mainly red, over in Peru, these mountains have stripes of lavender, gold, red, and even turquoise. When you finally leave the boat on the foot of the smoking hills, you begin your hike up. Stepping is difficult with your special boots. The soles are made specially to support high-degree temperatures, but it sure is hard to keep your balance. Before you know it, you're as close to the burning rocks as you can get. Your first impression is to get out of there as fast as possible. Conditions for human life are harsh over there. It's inhospitable, and everything about the place says you shouldn't stay for long. But you are also beyond curious. You might ask yourself how these rocks keep burning for so long. The science behind it is not too complicated. The rocks you're looking at are called shales. They are a type of sedimentary rock formed by clay minerals. Your guide explains that the secret to the smoke lies on the ground. The soil is formed by sulfur and coal. When they get in contact with oxygen, they spontaneously ignite, releasing the smoke you're now seeing. The few ponds in the region have very acidic water. Scientists say that this world region is the only one to show a negative pH. It means this water is naturally corrosive, so you don't dare drink it. Make sure to bring your own water bottle when leaving the ship. You spend a few hours there, but it seems like a whole day. The suits are heavy, and breathing through a gas mask is not your idea of comfort. At the end of the day, you head back to the ship, enjoying a beautiful Arctic sunset on the way. On the morning of your third day, you're in for a nice surprise. You're not heading out again. Instead, you're going to take a trip to outer space. Metaphorically, of course. Your guide talks about the connection between the smoking hills and Mars. Looking for life on Mars has been a journey all on its own, but recently, scientists discovered the exciting presence of jarosite on the smoking hills. And guess what? Jarosite is an abundant mineral on Mars. Experts think that this may indicate that Mars did have running water at some point in the past, since jarosite needs groundwater to form. This huge discovery may take science many steps closer to a breakthrough. Has life really existed on other planets in the solar system? Mars has been on the map for scientific research for being the most likely planet to have developed life. The atmospheric temperature now is unbearable for above-ground life, but it was similar to Earth's at some point. The most important proof needed is to find the evidence of running water. Right now, as we speak, the Curiosity rover is out there looking for any piece of information that can hint at the existence of life on Mars, past or present. Just out of curiosity. Curiosity, the rover has been exploring the surface of Mars for over 3,566 days so far. If you do the math, it makes for 9 years and 279 days. And in case you're wondering, why are we so eager to find life on other planets? According to NASA, the research for life on other planets can help us explain a lot about our own history. Where we came from, and maybe even where we're headed. And who could have guessed that scientists could begin to find answers for that in the Arctic tundra? That's exciting, right? Now, it's day 4 aboard the ship, and the expedition is coming to an end. Time to head back to mainland Canada. You just visited one of the world's most inhospitable places with a lot of impressions. Now it's time to tell us what you thought about the journey and what you learned along the way. Write it all down in the comments below.
25 light-years away from Earth, in the constellation Lyra, there's a young star, Vega. The brightest and one of the most famous, this star is twice the mass of our Sun. Vega is so brilliant, you can see it even at twilight when all the other stars disappear from the sky. Despite all the star's fame, astronomers have never seen a single planet orbiting Vega, until recently. Researchers have been observing the star for a decade or so when they spotted a curious signal. It might be Vega's first world we'll know about. If it did exist, it'd be a marvelous place. The planet would likely orbit so close to its host star that one day on it would last around 2.5 Earth days. The world would be the size of Neptune, and this ice giant is 4 times wider than Earth. Or it might even be as large as Jupiter. But the most impressive thing about this potential planet would be its temperature. The place could turn out to be the second hottest world known to scientists. On its surface, it'd be as hot as 5,400 degrees Fahrenheit. For comparison, the temperature on the surface of the hottest planet in the solar system, Venus, doesn't rise above 900 degrees Fahrenheit. The only place hotter than Vega's potential companion would be Kelt 9b. The temperatures on this exoplanet don't drop below 7,800 degrees Fahrenheit. Anyway, the candidate world would be closer to Vega than Mercury in our solar system is to the Sun. It could result in the giant planet puffing up like a balloon, and then even metals would melt in its scorching hot atmosphere. Unfortunately, the existence of the sizzling planet has yet to be confirmed. Astronomers think that the easiest way to prove it is by trying to spot the light emitted by the unusual planet. And since we're talking about planets, are there any worlds out there that resemble Earth? Astronomers have discovered and confirmed more than 4,000 exoplanets, but it's no secret that thousands of other candidates are still waiting for their turn to be detected. Of course, not all of these planets are like our Earth, but some are. For example, Gliese 667 cc. This world is only 22 light-years away from Earth. Scientists aren't sure if the planet is rocky, but they know the place is more than 4 times as massive as our planet. The star of Gliese 667 cc is a red dwarf. That's why it's much cooler than our Sun. So, the exoplanet is likely to be in its star's habitable zone. But this idea hasn't been confirmed yet. The Earth-like planet might be moving too close to the star. Then it can be regularly baked by its flames. Kepler 22b is much farther away than the previous world. If you wanted to reach that planet, you'd have to travel 600 light-years. This world, which is more than twice as large as the Earth, lies in the habitable zone of its host star. But it's unclear whether it's liquid, gaseous, or rocky. Kepler 69c is almost 70% bigger than our planet. It's also very, very far away, 2,700 light-years. It'd take you 54 million years to travel the distance that great in a modern spacecraft. Researchers aren't sure what Kepler 69c consists of, but they think it's likely to lie in the habitable zone. The planet's position in its solar system is like that of Venus and ours. But since the host star is only 80% as bright as the Sun, the planet shouldn't be affected by its heat that greatly. Kepler 452b is the most Earth-like planet astronomers have discovered so far. It resides 1,400 light-years away from our planet. Its host star is very similar to our Sun, and the planet, lying in its habitable zone, is 1.5 times the size of Earth. Scientists also think that Kepler 425b is likely to be a rocky world. Are any of these or other planets besides Earth suitable for life? There are 24 potentially super-habitable planets, and one of them met not one, but 2 criteria astronomers have for such worlds. KOI 5715.01 is 5.5 billion years old and around twice the size of Earth. It orbits an orange dwarf a bit less than 3,000 light-years away from our planet. Its surface temperature might be 4 degrees Fahrenheit cooler than that of Earth. But since the planet's atmosphere might have more heat-trapping gases, the place is likely to be super-habitable. Another potential super-habitable planet is KOI 5554.01. This world is a bit older than our planet, 6.5 billion years against our 4.5 billion. The exoplanet's size is likely to be the same as Earth's. The planet orbits its host star, a yellow dwarf, and the average temperature on its surface is 80 degrees Fahrenheit. What planets are visible from Earth? Mercury is the nearest to the Sun in our solar system, but since this planet is so close to the star, you can only see it just after sunrise, in the early morning, and at dusk. From up close, the place looks a bit like the good old moon. The planet doesn't have an atmosphere, and the temperatures on its surface are extreme, 800 degrees Fahrenheit during the day and minus 290 degrees Fahrenheit at night. Venus is the second brightest celestial object out there after the moon. It's one of our planet's closest neighbors. Also, it's the most similar to Earth in terms of gravity, size, mass, and average density. Unfortunately, you won't be able to see Venus's surface from Earth. A thick layer of clouds is securely hiding the planet. Jupiter can be either the third or fourth brightest object in the sky. It depends on Mars, which occasionally shines brighter than the gas giant. You can see Jupiter especially well in the summer. The gas giant's most famous feature is the Great Red Spot. That's an enormous storm that has been raging on the planet's surface for centuries. Even though the largest planet in the solar system looks like a solid sphere, you wouldn't be able to land on its surface. Jupiter is mainly made up of gases, mostly helium and hydrogen. Saturn is the second largest planet in the solar system. It's the last one of the 5 planets you can see from Earth with the unaided eye. Saturn is incredibly far from Earth, but its unique rings help you instantly recognize this colossal planet. It's a pity that Saturn's trademark feature is only visible in a telescope. By the way, more than 700 Earths would fit into Saturn. At the same time, the gas giant's density is a mere 1/8 of Earth's. This is why Saturn's mass is just 95 times greater than that of our planet. What planets in the solar system are closer to each other than the rest? Astronomers believe that Mercury is the closest to any other planet in the solar system. And that's quite shocking because, how about Venus? It orbits the Sun between Mercury and Earth. Isn't it supposed to be closer to our planet? Venus is indeed rather close to Earth, but only for a very short period in its orbit. The rest of the time, Venus is much farther away. But Mercury's orbit doesn't let the planet move too far away from the Sun, and it's closer to Earth more than 50% of the time. The same principle works with other planets too. Even gas giant Neptune is farther from Uranus than from Mercury. Most of the time, the 2 larger planets are on the opposite sides of the solar system. Their orbits sometimes do bring them very close to each other, but it happens very rarely. And how about planets outside the solar system? Astronomers have recently discovered 2 worlds traveling around the same star. Their orbits are often so close to each other that each planet looks like a huge full moon from the surface of the other. It occurs every 97 Earth days. These planets are about 1,200 light-years away from Earth. Their composition and size are different, but the distance between them is a mere 1.2 million miles. That's 5 times the distance between Earth and the Moon, and it's closer than any other planets astronomers know about. One of the newly found worlds is more than 4 times as massive as our Earth. It's likely to be rocky. The other is a gaseous planet the size of Neptune and almost 8 times as massive as our planet. Scientists haven't figured out yet how such dramatically different space bodies ended up in such similar orbits.
Now, did you know that our sun is actually green? Okay, I'm kidding. But in reality, it's all colors you can imagine at the same time. Wait, what? I know it sounds like a joke, but I'm being serious. Can't you tell? In fact, our sun contains absolutely all the waves of the light spectrum. It's simultaneously red, blue, green, yellow, you name it. Where do you think rainbows come from? When sunlight gets reflected off water droplets in the air, it splits into a bunch of colored waves that we can see individually. And when they're all together, we see a white ray of light. Our eyes are unable to perceive the concept of all colors at the same time, so their combination seems white to us. Wait, you might say, why white? Isn't the sun yellow? Yep, it's yellow too, but please don't stare at the sun just to make sure. It appears white when we see it from the International Space Station. This is the sun's real color as our eyes perceive it. The sun gets a yellowish hue when its rays get scattered in Earth's atmosphere. Our atmosphere doesn't let the blue rays of the spectrum pass very well, but the red ones? Hey, sure, why not? By the way, that's why the sky seems blue to us. The atmosphere scatters the blue color all over the place. During sunrise and sunset, short blue waves get reflected, but the long red ones reach us perfectly. That's why we see sunsets as pink, orange, or red. But what would happen if the sun had a different color? To answer this question, let's quickly repeat what we've learned. 1. The sun has the whole color spectrum in it. 2. Our atmosphere is like blue rays? Nope. Red rays? Anytime. So you probably already guessed what would happen if the sun was, let's say, red. The whole world would look like it does during sunsets. Not bad, huh? We wouldn't even have to wait for the evening to admire the scarlet sky. Orange water and a bright red moon. Yeah, it would be darker than what we're used to, but still not bad. Oh, by the way, one day, the sun will actually turn red. When its life comes to an end, it will expand and gradually turn into a red giant before finally burning out. But it's not going to be so much fun for us. So let's hope we won't be around to see that moment. I know I won't. Hey, I've got a party to go to. Okay, now, what if the sun was green? Well, the truth is, the sun is green. So here's your dialogue.
Wait, are you kidding me? Didn't you just say that it's white?
Ooh, good job on that, by the way. Well, not exactly, bud. The sun just looks white, but technically, it has a temperature of around 10,000 degrees Fahrenheit, and the pink wavelength of the sun's spectrum corresponds to the green-blue hue. But to make sure that the sun is green, we need to drown out the rest of the visible spectrum. Then our atmosphere will let through a pure green color. And what'll happen then? Well, everything will be green, and everything will also be a bit darker. Well, face it, it's not easy being green. Okay, moving on. Now let's paint the sun blue. Blue stars actually do exist. They're called blue giants. Fortunately, our sun is not one of them. Why fortunately? Well, because if it was a blue giant, it would be a young, beautiful, unimaginably large, and very, very hot star. See, our red is hot, blue is cold logic doesn't apply to stars. The hottest stars are white and blue, and the coldest are yellow and red. Yeah, our sun is actually very cold compared to other stars. Now, take the average temperature in your city, but multiply it by hundreds of thousands. Yeah, we're struggling with global warming here, but global burning? No thanks, blue giants. Anyway, let's imagine that the sun turned blue. How would we see the world? Surprisingly, nothing would change. Remember how I said that the atmosphere scatters blue light? That's why, in this case, everything would remain almost the same. Maybe the sky would get bluer, but we wouldn't see much difference. And finally, the darkest, pun intended, option. What if our sun turned black? Stock up on lamps and candles because there is no more light. People use electricity all over the world 24/7. We also can't see the moon anymore. After all, we can observe it these days only because the sun's rays get reflected off of it. Now, the only thing we still have to illuminate our nights are stars, but they don't help us much. Good thing this scenario is totally unrealistic and there are no black stars, right? Well, yeah, there are no black stars, and still our sun will eventually become completely black one day. And I don't mean a black hole. I'm talking about black dwarfs here. You've probably heard of white dwarfs, maybe even seven dwarfs. When a star like our sun is about to finish its life, it expands and turns into a red giant. And then, gradually losing its upper layers, it turns into white dwarfs. Since they no longer produce fuel, they slowly cool down. All that remains is a small core, living out its life and burning bright. And when the star cools down completely, it turns into a black dwarf. But you've probably never heard of them. Why? Because, surprise, surprise, they don't exist. And no, I was not lying. The thing is, a star needs about 1 quadrillion years to turn into a black dwarf. And our universe is still a baby. It's only about 14 billion years old. So no star has reached this stage yet. Even the most ancient of them still emit a little light. That's why black stars are just a theory. And it's unlikely that we'll ever see such a star at all. But remember the famous saying, the stars that we see at night are already ghosts because their light has reached us only now. Well, that's a myth. They're all still alive. Why am I telling you all this? Well, let's imagine that our sun turned into a black dwarf. The entire solar system would immediately get plunged into absolute darkness. It would also be terribly cold. The moon would leave its orbit and crash into Earth. Wait, no. Let's overlook this moment and assume we're still alive. Fortunately, we wouldn't freeze instantly, as you might think. Earth's core has its own temperature, more than 9,000 degrees. but the temperatures on the surface of the planet would still immediately drop to 32 degrees Fahrenheit. The core would gradually cool down. Every 2 months, its temperature would drop by 2 times. In just 2 months, Earth's surface temperature would be minus 190 degrees, and in a year, it would reach minus 450 degrees. Most plants would disappear pretty quickly, not because of the cold, but because of the lack of photosynthesis. Others would live a little longer thanks to the oxygen still remaining in the atmosphere. And, oddly enough, trees would survive for a very long time. They have a slow metabolism and get sugar from the ground. The upper layer of the oceans would freeze very quickly. Fortunately, this thick crust of ice would insulate deep waters, so the entire ocean wouldn't freeze for some time. Marine creatures would be doing pretty well. They existed long before us and are already used to crazy temperature changes, the lack of oxygen and food, huge pressures, and other joys of deep-sea life. And what about us humans? Well, first of all, we'd start getting sick. Without vitamin D, people would face a huge number of different health problems. Also, our bodies need sunlight to produce melatonin. This melatonin helps us understand when we should go to bed and wake up. If people didn't have this hormone, their bodies would get very confused and wouldn't understand whether they needed to sleep or not. That would mean insomnia for many people. The Hubble telescope orbits our planet, looking out at the big unknown universe. Since it's out of our atmosphere, the Hubble can see way further than telescopes on land. No clouds up there. This guy helped us confirm the theory about supermassive black holes in the center of galaxies. It also discovered a whole bunch of new galaxies, including the world's oldest one, which is about 8 billion years older than our own. But let's travel 25 light-years away to another special star, Fomalhaut. It's one of the brightest stars in the night sky, and it's in the constellation Southern Fish. It's almost twice as big and heavy as the Sun. If you look at it from far away, you can see a bright yellow disk around it. It's a debris disk full of bits of space rock, and it's huge. Its width is about 25 times the distance from the Earth to the Sun. Scientists were curious about it. Was all this space dust going to get smushed together and become a planet one day? But then they saw something else. Right there, through all that debris, was a massive, mysterious object. A large yellow dot orbiting the star. It looked like it was skating around a cosmic ice rink. So, in 2008, scientists announced they had discovered an exoplanet called Fomalhaut b. It was the first planet outside of our solar system that we could actually see with our own eyes. It's hard to know how heavy it is, probably like a couple of Marses put together, and it lives pretty far from its host star, about 4 times the distance from the Sun to Neptune. 1 year on the planet would be the same as 1,700 Earth years. We'd all be babies over there. So, one question. Does the planet even really exist? Scientists sat around arguing about it. Then, in 2012, the trusty Hubble telescope came up with some new data. It was real all along. If it was a gas giant like Jupiter or Saturn, that would make it incredibly young, 10 times younger than Earth. And all that dust around it seems to shine non-stop. You'd have to wear sunglasses 24/7. But now, it's disappeared again. Nothing but a donut of debris. So, maybe it was destroyed by a giant asteroid, like the one that wiped the dinosaurs off the face of the Earth. Or it may have been crushed by a rogue planet. These are planets that fly around the galaxy without a clear orbit. Maybe the dust is all that's left from a head-on collision. Or maybe something went crazy in the planet's core, and it exploded from within. Scientists now believe that Fomalhaut b was never actually a planet in the first place. It was just the leftovers of 2 big rocks smashing together. From far away, that kind of massive collision would actually just look like a yellow dot. These 2 colliding space rocks must have been at least 125 miles wide. That's like DC to Philadelphia wide. But this isn't the first time a planet's just up and disappeared from view. Scientists thought they'd found an Earth-sized planet orbiting our neighbor, Alpha Centauri. They called it Alpha Centauri BB, not exactly flashy. Plus, in the end, it turned out it didn't exist. Oops. Scientists make mistakes, just like the rest of us. Not long ago, they thought there might be life on Venus. They found traces of a special gas, phosphine, which can be a sign of life. It was the top story for a month. But then, someone decided to double-check the data. There was some phosphine floating around, but not nearly as much as they thought. Travel back in time a couple of hundred years, and you can find even sillier mistakes. Back then, people believed that the sun revolved around the Earth, and that our planet was the center of the whole universe. That's because they didn't have fancy equipment to measure stuff. People saw the sun rise in the east and set in the west. That was enough to say that the sun revolved around us. So, what happened to that planet? Basically, the Hubble took a photo of the whole star system, but since it's so far away, the photo came out kind of blurry. Scientists just saw a large yellow dot and assumed it was a planet. Scientists don't usually get photos of far-off planets. They normally have to use math to find them. Space objects are in a constant dance with one another. The dance gives off a lot of energy, like gravitational energy and light energy. It's like this. Say your friend is hiding behind a corner. You can't see him, but you can see his shadow on the floor. It's kind of like what scientists do when they look out into the stars searching for planets. So, big deal, a planet vanished billions of miles from here. But what if our perfectly balanced solar system were to lose one of its planets? You better believe it would affect our lives. Mercury's up first. Good news, it's too small to have a gravitational effect on our planet, so we wouldn't even notice if it went missing. Next in line is Venus. This hot planet is sometimes called Earth's twin sister. It's completely uninhabited, of course. Other than that, Venus is one of the brightest spots in our night sky. Pull it out of the solar system and whoa, it's much darker at night. But still, not exactly a big deal. Mars. Life without Mars might even be good for the Earth. There's an asteroid belt between Mars and Jupiter. Mars's gravity can grab an asteroid from the belt, spin it around, and catapult it toward us. Without Mars, the asteroids would stay in place thanks to Jupiter's gravity. Jupiter's heavier than all the planets in our solar system combined. It holds back the asteroid belt, and its gravity is actually strong enough to affect the Earth. A couple of thousand years after it disappears, we'd notice big changes. We'd move closer to the sun, which means a couple of things. 1, we'd have much hotter weather all year round, and 2, our days, weeks, and years would be shorter. Saturn, Uranus, and Neptune are all too far away for us to notice if they go missing. That just leaves one. No, not Pluto. What if the moon disappeared? Basically, chaos. The Earth would tilt even more than it already does, and the weather worldwide would go crazy, even crazier than now. It might even lead to a new ice age. The Earth would start spinning a lot faster, so instead of 24 hours in a day, we might have anywhere between 6 to 12. And even though nights would be a whole lot shorter, they'd also be darker than ever. When we see the moon, we're actually seeing the sun reflecting its light off the moon, and even a new moon is usually the brightest object in the night sky. If the sun were to disappear from our sky, it would be pretty much game over. This star is the center of our whole solar system. Without it, the orbits of all the planets would collapse, and we'd move around in complete chaos. The Earth, the Moon, and all the other neighboring planets would just shoot out into the universe, heading for, well, we just don't know. Daytime would be a thing of the past. We'd need the sun for that. So it would be nighttime forever. We'd probably never see the moon again. We'd probably never see anything again. The Earth would get colder and colder, and all the water on the planet would gradually freeze. But what if the sun turned into a black hole? We might still orbit around it. Hopefully, we're far enough away from it to stay safe. Mercury and Venus might be swallowed up, but we might get lucky. So we'd stay where we are, but we wouldn't have the sun to warm us. If it happened slowly enough, we might be able to adapt. We'd need a new power source, a new light source, and plants would have to adapt to get their energy from somewhere else. We'd probably need to build a huge tent-like thing over every city, forest, ocean, or we might just jump ship and move to another planet.
In May 2024, stunning auroras adorning the night sky demonstrated all the power that solar storms emit as radiation. But sometimes, our sun does things that are far more destructive. I'm talking about solar particle events. During these events, blasts of protons coming directly from the surface of the sun can shoot out like giant cosmic searchlights. According to records, an extreme particle event hits Earth every 1,000 years or so. It often causes bad damage to the ozone layer and increases levels of ultraviolet radiation closer to the surface of our planet. Luckily, Earth's magnetic field acts as a powerful protective cocoon for our planet, fending off electrically charged radiation from the sun. In its normal state, this field functions like a ginormous bar magnet, with field lines rising from one pole, looping around the planet, and dropping at the other pole. This pattern is sometimes called an inverted grapefruit. This vertical orientation of the magnetic field at the poles allows some ionizing cosmic radiation to get through the field as far down as the upper atmosphere. There, it interacts with gas molecules and produces the glow we know as auroras. But over time, Earth's protective bubble changes. In the past century, the North Magnetic Pole moved across northern Canada at a speed of about 25 miles per year. Plus, it weakened by more than 6%. Even more shockingly, according to geological records, there have been periods of time as long as centuries and millennia when our planet's magnetic field was super weak or entirely absent. But we'll talk about those tragic times later. It's easy to imagine what our planet would look like without its protective bubble if you look at Mars. The red planet lost its global magnetic field long ago. And once this field disappeared, most of Mars's atmosphere vanished too. In May 2024, a strong solar particle event hit the planet. It disrupted the operation of the Mars Odyssey spacecraft and made radiation levels at the surface of the red planet rise around 30 times higher than what a person receives during a chest X-ray. The sun's outer atmosphere constantly emits a changing stream of electrons and protons, the solar wind. At the same time, the surface of the star also produces bursts of energy, mostly protons, during solar particle events. These bursts of energy have a connection to solar flares, extremely powerful bursts of electromagnetic radiation that can last from minutes to hours. Protons are way heavier than electrons and carry more energy. That's why they can reach lower levels of Earth's atmosphere, exciting gas molecules in the air. These excited molecules emit X-rays invisible to the unaided eye. Dozens and hundreds of relatively weak solar particle events happen during every solar cycle. Now, let's speak about solar cycles for a minute. You see, from a distance, the sun seems to be calm and steady, but if you zoom in, you'll see that its surface is constantly seething and churning. It keeps transforming from a uniform ocean of fire to a chaos of warped plasma and back again in a repeating cycle. Every 11 years or so, the magnetic field of our star gets tangled up. Imagine a ball of tightly wound rubber bands. That's what it looks like at such moments. And then, at one point, it snaps and flips completely, turning the North Pole into the South Pole, and vice versa. Right before this event, the sun steps up its activity. It starts to spit out giant blobs of fiery plasma, emit powerful streams of radiation, and grow planet-sized spots. This period has the name of solar maximum. It's a rather dangerous time for Earth, since it gets regularly hit by solar storms. Such storms have the potential to disrupt communications and damage power infrastructure. Even worse, solar storms can harm astronauts working in space and even make satellites crash into the planet. As the cycle ends, it fades back to the solar minimum, and then a new cycle begins. Anyway, back to our solar particle events. Researchers have found traces of extremely strong solar events happening throughout the history of Earth. And some of them were thousands of times stronger than anything our modern instruments have ever recorded. Such extreme solar particle events happen approximately every few millennia. The most recent one occurred around 993 CE. Beyond the immediate effect they have, solar particle events can kickstart a chain of chemical reactions in the upper atmosphere. And these processes often lead to depletion of ozone, which isn't a good thing. Ozone absorbs harmful solar UV radiation, which can damage not only our eyesight, but also the DNA of living beings. Plus, changing the amounts of ozone in the atmosphere can impact the climate. In a recent study, researchers used large computer models to examine how extreme solar particle events affect Earth. They found out that if a solar proton event arrives during a period of time when our planet's magnetic field is very weak, then ozone damage can last for 6 years, and the level of UV radiation might increase by 25%, boosting solar-induced DNA damage by around 50%. And apparently, this dramatic combination of a weak magnetic field and extreme solar proton events happens quite often. And some researchers believe that it may even explain a few mysterious occurrences in the past of our planet. For example, the most recent period of weak magnetic field started 42,000 years ago and lasted for around 1,000 years. This period included a temporary switch in the North and South poles. Several major evolutionary events happened during that time. For example, the last Neanderthals disappeared in Europe, along with the extinction of marsupial megafauna in Australia. Yeah, sadly, we won't see any giant wombats and giant kangaroos anymore. One more, even bigger evolutionary event might also be linked to Earth's geomagnetic field. Multicellular animals appeared at the end of the Ediacaran period, which started around 635 million years ago, and it occurred after a 26 million year period of extremely weak or even absent magnetic field. The rapid evolution of different groups of animals in the Cambrian explosion, about 539 million years ago, might have also been related to high UV levels and geomagnetism. The simultaneous evolution of hard body shells and eyes in multiple unrelated groups could have been necessary to detect and avoid harmful incoming UV rays. A complete reversal of Earth's geomagnetic poles might have a serious impact on the climate of our planet. Luckily, such flips don't happen overnight. The entire process stretches over thousands of years. Plus, even though the magnetic pole weakens during a pole reversal, it doesn't disappear completely. That's why the magnetosphere continues protecting the planet from cosmic rays and charged solar particles, even though there might be some amount of particulate radiation that will make it to Earth's surface. Our planet's magnetic fields are generated by moving electric charges. If some material allows these charges to easily move in it, it's called a conductor. Metal is a great conductor, and we often use it to transfer electric currents from one place to another. In this case, the electric current's negative charge, called electrons, move through the metal. The current is what generates a magnetic field. Earth's outer core is made of liquid iron and nickel. In other words, there are layers and layers of conducting material inside our planet. Currents of charges are constantly moving throughout the core, and the liquid metal is also moving and circulating there, generating the magnetic field. This magnetic field, in turn, produces something resembling a bubble around the planet. It's called the magnetosphere, and it's located above the uppermost part of the atmosphere. This layer shields and deflects high-energy cosmic ray radiation, which otherwise would be extremely hazardous to people and other forms of life on Earth. The magnetosphere also interacts with the ionosphere, the layer of our planet's atmosphere containing loads of ions and free electrons and capable of reflecting radio waves. The interaction between these two layers and magnetized solar winds is what scientists call space weather. The solar wind is normally mild, and there's no space weather whatsoever.